To begin our journey down Terraform, we first of all going to start with a section focusing on an introduction to infrastructure as code. And to really set the stage for that, let's start with module 1. What is infrastructure as code? Well, to understand that, we first need to think about why we got here. Why was this invented in the first place? And one of the big problems in IT departments is this, where a developer perhaps wants some infrastructure and they put in that order request, and then it feels like we're passing a piece of paper around between teams until ultimately somebody delivers back to the developer, usually perhaps the server team, that set of infrastructure. And so all these automation tools, infrastructure as code tools, came about as a way to really, get over this traditional request model of passing everything around between teams. And so ultimately we have the infrastructure as code way. You can see here, and as we get further into this course, we can define our infrastructure as code. That's exactly what's implied by infrastructure as code. We declare that infrastructure as code, and then we can push it out to our target location. Now, infrastructure as code, or IaC for short, is the management of infrastructure components like storage, networking, servers, allowing you to run application workloads. However, it is not limited to just infrastructure itself, as it also allows you to manage things like containers, app services, and the like. It's important that it is done using code, using a descriptive model. This means you create an outline, like a blueprint, of the desired state of the infrastructure you want to achieve. Some of the important infrastructure as code characteristics are as follows. We have idempotence, which means you'll always get the same end result, no matter how many times you run that deployment. We have the concept of immutable, referring to the fact that you can run the same code over and over, even in different environments like test, dev, staging, and production, only requiring minimal changes. And last, we have lights out deployment, referring to the automation part of the entire process. In addition, we have some benefits that we need to cover with infrastructure as code. Why are we doing this in the first place? Well, one, it's reliable. While it could take some time and effort to get your infrastructure as code deployment templates or scripts ready, working with the development team to iron out any particulars that we need to get right, once you have them, they are reliable and allow you to run stable deployments over and over. And this is instead of trying to memorize all the steps during that manual deployment process. One builds the template or script once, and the outcome will always be the same. It's also incredibly fast, which doesn't specifically refer to a faster provisioning as such, but it should be clear doing deployments in a manual way will always be more time consuming, especially when the job is repeatable in nature. And so there's this concept here of lots and lots of templates that can be reused over and over again, maybe some parameters to change configurations. And then we have scalability, which is another huge benefit, allowing anyone to easily deploy a larger amount of identical resources, even repeating the same deployment across those different environments. Now, if we look at infrastructure as code and compare it to configuration management, you can see the contrast on the left and right here. On the left, infrastructure as code is responsible for infrastructure automation, provisioning of platform resources in this case. These could be virtual machines, Azure app services, VMware storage, etc. And this is achieved using infrastructure as code tools, Terraform being one of them, but also ARM templates, and in AWS you have CloudFormation templates. On the right, we have configuration management. Configuration management tools like Ansible, Chef, Puppet are also declarative typically in nature, and they allow us to define configuration settings once provisioning is done. So these are things like installing a piece of software like an agent, an antivirus agent's a good example, in your virtual machine, update a certain setting or something like that. And again, Chef, Puppet, PowerShell, DSC, Ansible are good examples here. Now with that, let's move on a little bit to infrastructure as code in Azure. As you can see here, plenty of options available to us. We have Azure Resource Manager templates. This is the main infrastructure as code solution available in Azure. And essentially, again, uses ARM templates that you're probably familiar with if you've been in Azure for a while. And it's based on a JSON type syntax. You can deploy, change, or remove Azure resources. Templates can be authored using Visual Studio Code, Azure Portal, or any other editor environment, even Notepad if you really wanted to use it, but you'll obviously get along much better with Visual Studio Code. Another option is Azure PowerShell modules. So you can also define infrastructure just using Azure PowerShell modules as well. Not typically seen as infrastructure as code because you're not declaring. This is more of a scriptable language that you're using there, but certainly can do the job as well. And that's also similar with the Azure CLI. Now you may be more familiar with PowerShell, but Microsoft released a CLI as part of Azure that you can access, and it's very similar to PowerShell. Whole bunch of commands you can run basically, against your Azure infrastructure. And last, outside of the core Azure tools, you can also look to things like Terraform, Pulumi, Ansible. In our case, we're going to focus primarily on Terraform. That's really the tool we're focused on here. How do we utilize Terraform, define our infrastructure as code, and deploy to Azure?